Hello, my name is Renuá Meireles Almeida, and I'm here to talk a little about the work, fitness value curves prediction, and evolutionary process of genetic algorithms. So, due to their stochasticity, genetic algorithms are usually executed several times under the same parameterization to infer more reliable about the behavior and the results obtained. Therefore, this work aims to reuse the experiences obtained in the executions and train a machine learning model to predict the maximum, average, and minimum fitness values that emerge during the evolutionary process, and this only with the knowledge of its initialization parameters. So, moving on to the methods, the first step consists of defining the model's features and targets. The defined ones consist of 7 initialization parameters in addition to the current generation. Among these parameters, we have the population size, the stop generation, the crossover and mutation probabilities, the elitism, and finally, the function bounds. In this way, the model will predict the maximum, average, and minimum fitness values. To train the model, the features and targets of 5,000 executions of an algorithm maximizing the described function were collected, and the initialization parameters were uniformly randomized according to the range restrictions in Figure 2. But for the evaluation of the model in predicting the whole evolutionary process, the features for each generation are created by simply replicating the initialization parameters for all generations, and for the feature current generation, a sequence of integers from 1 to g is generated, where g equals to the stop generation. So here in the results, it is possible to observe in Figure 3 the performance of the model, where we can see the efficiency in predicting the maximum and average values, but errors stand out in the prediction of minimum values. The reason for these errors is more evident when analyzing the fitness curves generated in the evolutionary process in Figures 4 and 5. In Figure 4, it is possible to observe the original and predicted curves under the parameterization of 45 for population size, 65 for stop generation, 82% of crossover, 16% of mutation, elitism defined in 9, and function bounds in -9 and 3. The most irregular curves, we have the real values, and the predicted values can be approached considerably. Right in the figure below, we have a parameterization with a broader function domain, and even thus, the predicted values indeed approximate the real ones. So, the results presented so far indicate a great potential in this type of approach. Despite the errors present, in terms of graphical visualization, the predictions adopt behaviors very close to the real ones. Thinking about it, one can see the possibility of developing a tool that dynamically shows the influence of the initialization parameters through fitness visualization. In addition, there are good alternatives to be explored and deepened from this work. For example, the analyzing the relation to the amount of data needed to train the model, the use of more complex problems, generalization of similar problems, among others. And that's it. I'm glad you've come so far. Feel free to share any thoughts or questions.